Hello, let's solve a problem. A summation. Find summation r equal to 1 to n minus 1 whole power r minus 1 ncr into hr. Here this hr is harmonic. Fine. Harmonic in a sense that hr is 1 plus 1 by 2 plus 1 by 3 plus and so on plus 1 by r till 1 by r because it's hr, right? Now let's the given summation b is, then this becomes summation r equal to 1 to n minus 1 whole power r minus 1 ncr into hr is 1 plus 1 by 2 plus 1 by 3 plus and so on plus 1 by r. Now let's write this harmonic series in terms of integrations, which will be easier to solve, right? Now as you can see, these can be written as 1 plus 1 by 2 plus 1 by 3 plus and so on. This can be written as if for 1 x, for 2 x square by 2, for 3 as x cube by 3, right? That is, these two will equals when x equal to 1. Fine. When x equal to 1, LHS and RHS are same, right? Now this can be written as integral, right? Integral, how will you solve? Integral 0 to 1 dx. Now as you can see, integral dx is 1. Sorry, integral dx is x. When substitute the limits 1 minus 0, it is 1. Similarly, if here it will be integral 0 to 1 x, then it will be x square by 2, because the integration limits are 1 to 0, then it becomes 1 by 2. Fine. Similarly, this is fine. Now let's write this summation as integral 0 to 1 plus x square plus and so on plus x power r minus 1 into dx. So this, as you can see now, this series is in a geometric progression, right? Which can be written as you can see, the dx value ranges from 0 to 1. The common ratio is x here now, which lies between 0 and 1. So it will be a into a value is 1 here, 1 minus x into whole power r by 1 minus x, right? Here it is, the geometric progression, right? A into 1 minus r power n by 1 minus r. Here a is first term, r is a common ratio, and n is up to terms, the number of terms, into here it is dx. Fine. Now substitute this integral in the given question, which is s equal to summation r equal to 1 to n minus 1 whole power r minus 1 ncr into integral 0 to 1 minus x power r. Sorry, this is 1 minus x power r by 1 minus x dx. Fine. Now let's interchange this integral and the summation. Let's keep this integral out of everything. Integral 0 to 1, fine, integral 0 to 1 summation r equal to 1 to n minus 1 whole power r minus 1 ncr into 1 minus x power r by 1 minus x into dx. Fine. Now, let's do the summation first. This is R. Here, as you can see in the denominator, there is no R dependency. So, integral 0 to 1, keep it at the left hand side. Then this becomes summation R equal to 1 to n minus 1 whole power R minus 1 into NCR minus summation R equal to 1 to n. We are just expanding this part, right? Minus 1 whole power R minus 1 into NCR into x power R into dx. Fine. Now comes the interesting part. This is x. Fine. Now let's calculate first this part, which is summation R equal to 1 to n minus 1 whole power R minus 1 NCL, which can be written as, you can just simplify this, 1 minus summation R equal to 0 to n minus 1 whole power R NCL. You can just expand this, both will be the same. This is a 0, right? How it will be 0? Let's prove. You know this x plus y whole power n formula is summation R equal to 0 to n, x plus y whole power n is summation R equal to 0 to n NCR x power n minus R into y power R. Fine. Now if you take, let x equal to 1 and y equal to minus 1. If x equal to 1, y equal to minus 1, this will be 1 minus 1. 0 power n is 0. If summation R equal to 0 to n NCR to x power n minus R, x is 1 power n minus R into minus 1 whole power R. This 1 power n minus R is 1. Then this becomes summation R equal to 0 to n minus 1 whole power R into NCR, which is equal to 0. Right? Then this part doesn't contribute. This is equal to 1. Fine. Similarly, the second part, summation R equal to 1 to n minus 1 whole power R minus 1 NCR x power R can be written as 1 minus summation R equal to 0 to n minus 1 whole power R into NCR, which can be written as 1 minus of 1 minus x whole power n. The same form here, x plus y whole power n, you can apply for this case. You'll get this. Now substitute these two terms here in the given s. Now s becomes integral 0 to 1 1 by 1 minus x into, the first part is 1 minus, this is 0, 1 minus 0, which is 1, and this part, the second term is this minus 1 plus 1 minus x whole power n into dx. So 1 1 will get cancelled and you are left with s equal to integral 0 to 1, denominator is 1 minus x, this is 1 minus x whole power n into dx. As you can see this will become integral 0 to 1 1 minus x whole power n minus 1 into dx. Now this is just a simple integration, which is 1 minus x whole power n minus 1 plus 1, which is n. Similarly, n minus 1 plus 1, which is n. As you can see, there is a, you need to differentiate again 1 minus x, you will get a minus sign. Then this will become 0 to 1. Integration limits are this. So this is minus 1 by n. It's a constant, keep it out. Now 1 minus 1, 0 power n, right? When x equal to 0, it becomes 1 power n. This is minus 1 by n into 0 power n is 0 minus 1. Finally, this becomes 1 by n. So finally, our solution is s equal to 1 by n.